Now in this lesson we're looking at Module 1, Searching for Patterns. Topic 1 is about quantities and their relationships. In Lesson 1 we're going to be looking at understanding quantities and their relationships. So look at this next one. Before we get started though, I need you to either scan in using the QR code right here with your phone and take an attendance that way, or click on the word attendance and it will go directly to the Microsoft form and in order to fill out for the attendance. Now look at this first problem right here. Emma bought a brand new video game. The graph right here describes the number of hours Emma spent playing the game over a period of 7 days. I want you to label the axis. What does the highest point in the graph represent with respect to the scenario? And what is the lowest point? Pause me right here while you come up with your answers. In this next part right here, you will see that Emma bought a new video game, and right here you see on number 1, how would you label the x-axis? Well, the x-axis right here is labeled with time and days. So this is your independent quantity right here, and time is being measured with the unit of days. Now over here on your y-axis, this is your dependent quantity. Time is being measured right here and is being measured by the number of hours Emma spent playing the video games. Now the highest point on this graph right here is at 3-4. So when I come down here, I see that Emma in 3 days she has spent 4 hours playing the video game. Now to find the lowest point, you see on the first day that Emma only played 2 hours of video games, and on the 6th day she played 2 hours of video game. In today's lesson, you're going to be understanding about quantities and relationships. You're going to be identifying the quantities and their relationships for real-world scenarios. You're going to be matching them. You're going to use appropriate scales for modeling a scenario, and you're going to identify key characteristics of graphs. Here you see the Tennessee State Standards, and then you have the key terms dependent quantity and independent quantity. Now look at this next slide right here. Have you ever planned a party? Well, you may have purchased ice, gone grocery shopping, selected music, made food, or even cleaned in preparation. Well, many times these tasks depend on another task being done first. For instance, you wouldn't make food before going grocery shopping. Now would you? You're not going to invite a ton of people over without having food to feed them. That wouldn't be a smart thing to do, and they'd be kind of grouchy. Look at this next one, dependent and independent quantities. Look at this first black section right here. Dependent quantity is when one quantity depends on another. You have the y column, which is the vertical of a graph, and the dependent quantity is called the output, or we could refer to it as f of x equals, or it can be referred to as the y. When we look at independent quantity, we have a quantity that depends on nothing else. The quantity that dependent depends on is also the x-axis, or the x row, which is horizontal. The independent quantity is the input, or the x. This does not change right here. Now the dependent quantity is the one that is being forced to change by the independent quantity. The independent quantity does not change. Here's a sentence to use when you're trying to decide whether it's dependent or independent. The blank depends upon the blank in order to figure out, does it make sense? Now look at the T-chart, or the table to the right here. Independent is also the input, which is also the x. The dependent is the output, which is also called the y. Now, if you put in x, the input, and place in this function right here, f of x equals to 3x plus 4, you see 1 is the independent. 3 times 1 plus 4 will give you 7. So this is the output right here. The 1 did not change. It was the answer, the y, that changed. Now the f of x can also be referred to as y equals 3x plus 4. So the f of x is the same thing as saying y. In this next part, you have the cost of shipping a package is based on its weight. I want you to identify the independent quantity and dependent quantity and use the sentence, the blank depends upon the blank. Now pause me while you consider which one is which. This next part, you see the independent quantity is the weight. The dependent is the cost of the shipping. So the weight did not change on the package. It is the shipping, the amount of money that you have to pay. It depends on how much the package weighs. So the cost of the shipping depends upon the weight. Look at this next scenario. Betsy is an office manager for the Gale Enterprise office building. One of her responsibilities is cleaning the office building's 500-gallon aquarium for cleaning. She must remove the fish from the aquarium and drain the water. The water drains at a constant rate of 20 gallons per minute. I want you to find the independent and dependent quantities. Pause me while you consider this. Now, Betsy, as an office manager for Gale Enterprise, she is letting out all this water. It is going out at 20 gallons per minute. Look at this part that is highlighted right here. So we have gallons per minute. Now I want you to think of D comes before the I in the alphabet over here in this right-hand side. So the dependent comes before the independent in this phrase, gallons per minute. Per is a key word to look for to help you define the dependent and independent phrase. Now, not all situations will have the word per, and sometimes the per will also each be used instead of per. So when I look at this right here, the D comes before the I in the alphabet, so gallons comes before minute. And the independent, you're looking at time, the unit of measurement is minute. When you're looking at dependent, the volume, you're looking at the unit of measurement as gallons. So gallons per minute, or dependent per independent. In this one, you have a graph, and I have gone ahead and put this in. So you see that the independent right here on the x-axis is looking at time, which is talking about minutes. And then the Y right here, instead of using volume, they use water. It's fine to use either one. And the unit of measurement that they're using is gallons. Notice that this is linear. It is decreasing from left to right. And it is decreasing at a steady rate of 20 gallons per minute. So you're decreasing. This is a linear graph right here, a straight line. And you're decreasing at 20 gallons per minute. It is constant. It is steady. Now, when you're looking at these and comparing graphs, while a person can describe the monthly cost to operate a business or talk about a marathon race, a pace a runner ran to break out a rural record, graphs on a coordinate plane enable people to see the data. So graphs relay information about data in a very visual way. The old saying, a picture is worth 1,000 words, well, it is, because you can use smooth lines or curves right here to represent relationships between points on a graph. Now, not all points on the graph will make sense. A lot of them will, but sometimes they will not. So we have different graphs right here. This is called an exponential graph right here because it is increasing from left to right. It is a smooth curve. This right here is called an absolute value graph right here. It is decreasing from left to right and then increasing from left to right. It is a V shape. This right here is a quadratic graph. It is a smooth curve. It's called a parabola. It is increasing from left to right and then decreasing from left to right. This one, graph G, is a piecewise. It is increasing from left to right. It stays constant and then it goes up. It is increasing from left to right. This is a piecewise graph, and this here is a linear graph on graph H. It is decreasing from left to right. It is steady as a straight line. It is constant. This next part, you have your eye on an upgraded smartphone. However, you're currently broke. Your brother will provide the funding as long as you pay him back with interest. He tells you that you only need to pay $1 in interest initially, and then the interest will double each week after that. You just consider his offer and wonder if this is really a good deal. I want you to identify the independent and dependent quantities and put me on pause, please. In this next part, you see that the independent quantity is time and you measure it by weeks. The dependent quantity is interest and you're measuring it in dollars. And I have already uploaded this for you. And so look at this scenario thinking, is this really a good deal? Well, the first week you pay $1. If you double that, 1 plus 1 is 2, double that, 2 plus 2 is 4, double that, 4 plus 4 is 8, double that, and you get 16. In doubling each time is 32, 64, 128, and it keeps on going up. So is it really a good deal? And you're going to use an exponential graph for this because you start out small and then it just keeps exploding and going up. This right here is a smooth curve and is increasing from left to right. This one, Jessie is a drum major for Oakland High School marching band. For the finale of the halftime performance, Jessie tosses her baton in the air so it reaches the maximum height of 25 feet. That gives her 3 seconds to twirl around twice and catch the baton. When it comes down, I want you to identify the independent and dependent quantities and put me on pause. Well, here you see that we're looking at 25 feet. We do not see the word per or each in here. And so the independent quantity is looking at time, and that is the x-axis, and time is being measured by seconds. The dependent quantity, you're looking at height, or you can look at distance or altitude, and the unit of measurement is feet. Now this right here is a parabola. It is a quadratic. So here, Jessie throws the baton up in the air. Here's the highest point, the maximum point, and then it comes back down and she catches it. So this is a quadratic, a parabola graph that we have. Now, Mickey loves skiing. He just hates the ski lift. To make matters worse, the ski lift has been acting up today. Mickey's using the GPS on his phone to track the ski lift's progress as it travels up the mountain. It moves at a steady rate of 500 feet per minute until it stops suddenly. Mickey calls his friends to tell them that he is stuck. They talk on the phone for 11 minutes until finally the ski lift begins moving again. I want you to identify the independent, dependent quantities and put me on pause while you do this. This next part, you see that in this scenario, the independent quantity right here, the x-axis, is time, and you're looking at minutes. And then the dependent quantity is distance, and the unit of measurement is feet. So right here is the key word per right here, feet per minute. So dependent, independent. Per is your key word, and here's the phrase. All you got to do is make sure you look for the word per, and sometimes they have it in there and sometimes they don't. So feet per minute. So right here, Mikey is at the bottom of the ski lift. He is increasing. He's going in time, and he's going up the mountain. Now he gets stuck on the mountain, so he talks to his friend for 11 minutes, and so this is constant, and then he starts moving again and going on up. So he is increasing. This is a piecewise because it has 3 pieces, a piecewise graph. Now, I want you to identify and match the independent and dependent quantities right here and see which ones match up. Put me on pause when you do this. The first one I have done for you, how far can you drive? And then I've matched it up with the amount of gas. Well, how far you drive depends on the amount of gas that you have in your vehicle. Now, pause me. I want you to come up with the others, matching up the dependent to the independent. Pause me. Looking at this one, I have matched these all up. Look at the color-coded, and these will put it together. Then, right on this next slide, you see that these are all matched up. Like number 1, the winner of a football game depends upon who scores more points. Number 2, how much you make depends upon the number of hours you work. Number 3, how much air condition you use depends upon the temperature outside. Number 4, your grade. Your grade depends upon the amount of assignments you've turned in. Number 5, your cell phone bill depends upon the minutes you used. Number 6, the cost of a speeding ticket depends upon how many kilometers you went over the speed limit. Number 7, time it takes to drive somewhere determines how fast you drive. And number 8, how far you can drive depends upon the amount of gas that you have. Look at this next one. Wesley is driving to visit her uncle who lives 467 miles away from her home. She travels an average of 74 miles per hour. So I want you to come up with the dependent and independent. And hint, look for the keyword. Put me on pause when you come up with your answer. Now, here are your your independent and dependent, and look for this keyword, miles per hour. Here's your keyword, per, and dependent, independent. So we have the dependent is talking about distance, which is being measured in miles. Your independent is time, and your unit of measurement is in hours. On this next one, Brinley draws different size spheres in a notebook. She knows there is a relationship between the surface area of the sphere and the length of its diameter. What is the independent quantity in this situation? So look through there and see if you see the keyword and per and or each, and if you don't, look for a phrase. You're looking for the dependent quantity. Put me on pause. Now, Brinley draws different size spheres in a notebook. So this one did not have the per or each, but it does have this phrase right here, surface area of the sphere. So this is your dependent right here, volume of the surface area, and your independent is the length of its diameter right here. In this scenario, Mimi knows there's a relationship between the number of trucks she washes and the time it takes her to wash those trucks. Identify the independent quantity and the dependent quantity in the problem situation. Now, put me on pause when you find that. Here, you see that there was not the keyword per or each, but you're looking at the number of trucks washed depends upon the time it takes to wash the trucks. So you have your dependent and independent quantities right here. On this next one, you have a scenario. So you're given 3 scenarios down below, and you're going to determine which graph best suits each scenario. You're going to write the number of the scenario to the graph you think matches it best. You're going to write your answer right here. Now, Darby knows a test with a possible total of 94 points, begins the test with a possible total of 94 points. She loses 3 points for every question she answers incorrectly. So find the graph that matches it to this scenario. Now, number 2, Heidi has 16 pennies in her piggy bank initially, and she doubles the number of pennies in her piggy bank every 8 days. And then scenario number 3, it costs $5 for Laura to enter the school's fall festival and 50 cents per ticket purchase. So right here, graph number 1, which scenario goes with it? Graph number 2, which scenario? Graph number 3, which scenario? Pause me when you find it. So here are your graphs. Graph 1 goes with scenario number 1. So this right here, since you're starting with 94 points and you're decreasing 3 points every time you have a wrong answer, it is a steady decrease, and it is linear, and it's going downhill from left to right. It is decreasing from left to right. Now, graph number 2 right here. Since this is, you're starting out with small and then it keeps getting bigger and bigger and just kind of explodes, you see that you're starting out small and then it explodes. This is an exponential function right here. It is a smooth curve. You're starting out small and just gets big really quick, really fast. Then right here on graph number 3, this one you have Laura who started out at $5. And then she purchased a ticket for 50 cents each time. It is a steady purchase, a steady growth. It is constant. It is linear. So you're increasing from left to right. Now, looking at this scenario, Farah drove to the lake. She was there for about an hour. Then Farah drove back to the house. The graph represents this scenario. I want you to come up with the dependent quantity. So pause me when you do that. Now, looking at the dependent quantity in here is the distance from Farrah's house in miles. So even if you did not have the scenario, you can look over here at the graph and immediately say, oh, okay, this right here is the independent quantity. This one is the dependent quantity. So I'm looking for dependent quantity, and this is what I'm looking for right here. In this next sentence, you see that you've got a lawyer's fee that's $180 per hour for a service. I want you to come up with the independent, dependent, and quantities and a function. Pause me while you do that. Down below, you see that the independent is the hours of service, and the dependent is talking about lawyers and fee, and here's your function. You have f of x equals 180. So you have per right here. Per would be like talking about x. $180 per hour for your function. On this next one, you've got a admission fee at a carnival that is $9. Each ride costs $175. Pause me when you come up with the independent, dependent quantities and function. Pause me now. Now, the admission fee right here, and coming up with the independent quantities, you're looking at rides ridden. Dependent is the total cost, and the function is g of x. This g of x, you can have any letter of the alphabet. It doesn't matter right here, as long as the x, whatever letter you use right here, matches this. So now the g of x equals $175 times x plus 9. So we have started out with $9, and each ride is $1.75. And this x will determine, you will substitute in ever how many rides that you rode in order to come up with how much you will pay. In this next scenario, you have Stan, who's a local delivery driver. He's to pay he's paid $4 per mile driven plus a daily amount of $75. I want you to come up with the independent, dependent quantities and functions. Put me on pause while you come up with it. In this next part, you see you have the keyword per. So you have 4x plus 4x. It's talking about your plus your $75 right here when you're looking at function. And here's your word per. So for the cost, the total pay is your dependent, and your miles is your driven is your independent. Now here's your function, s of x equals 4x plus 75. So I can put an x right here on per for x, and then put a plus right here on the word plus, and you have 4x plus 75. In this next one, you have Georgia, who's a florist who charges $15 per flower bundle plus $20 delivery charge. Come up with the independent, dependent quantities and functions, and pause me while you do so. Now, when you're looking at this, you see the independent quantity is flower bundle, total pay is your dependent, and your function is j of x equals 15x plus 20. So here's your keyword per. So 15x is your, what you would put down right here, plus 20. This is your function, 15x plus 20. Now, you have identified independent and dependent quantities. How can key characteristics of a graph tell a story? Well, when you're looking at this, you see that there are, you're looking at all different kinds of graphs. Sometimes it shows you where you pause, where you're increasing, decreasing, and also when you're looking at the summary right here, there are two quantities that change in problem situations, and the dependent quantity is the one that does change in a problem situation. It is the one that is being forced to change. The independent quantity does not change. It forces the dependent quantity to change. Now, looking at this one right here, you've got David who rode his bike to the park, which was 1.5 miles from his house. And after staying at the park for a few minutes, he rides his bike to the grocery store. I want you to come up with the independent and dependent quantities and circle the graph that matches this scenario. Pause me while you do so. Now, looking at this, graph B is the one that goes with this scenario. Across the bottom, you would put your time, and you're measuring this in minutes. And then that would be your independent a quantity right here. So independent would be time, and your minutes of measurement is being measured in minutes. Your dependent you would write right here, and your dependent would be your distance, and you're measuring it in miles. So this right here is your dependent. Distance and your unit measurement is miles. Here is your independent, and that is time, and is being measured in minutes.